everyone! In this video, we will look at two mathematical questions in the field of calculus. My team will explain more about the questions as well as the solution. Without further ado, let's get started!
A metal bar with an initial temperature at 25 degrees Celsius is immersed in a container of boiling water. It was observed that the temperature of the metal bar increases 3 degrees Celsius in 1 minute. Determine the time required for the metal bar to reach 85 degrees Celsius. Based on the instruction, it is stated that a metal bar is immersed in a container of boiling water. This means that the temperature of the container, capital T container, which is the constant temperature of the surrounding medium, is the same with the temperature of the boiling water. So, capital T container will be equal to 100 degrees Celsius. Also, it is stated that the initial temperature of the metal bar, which is capital T, is equal to 25 degrees Celsius at time T equal to 0. Then, the temperature of the metal bar increases 3 degrees Celsius in 1 minute. So, it can be concluded that at time T equal to 1, the temperature of the metal bar, capital T, is equal to 28 degrees Celsius. The temperature of the metal bar increases at a rate proportional to the difference between the metal bar temperature, capital T, and container temperature, capital T container, as we have d capital T over dt equal to K times bracket capital T minus capital T container, where K is the constant of proportionality. Then it will be d capital T over dt equal to K times bracket capital T minus 100 as capital T container is equal to 100. Then, it is required to obtain the time T at which the metal bar temperature, capital T, reaches 85 degrees Celsius.
We have the linear and separable differential equation, which is d capital T over capital T minus 100 equals to k dt. The next step is integrating both sides, and we get ln capital T minus 100 equals to kt plus c1. The next step is inserting exponent onto both sides, and we get exponent to the power of ln t minus 100 equals to exponent to the power of kt multiplied with exponent to the power of c1. The next step is capital T minus 100 equals to exponent to the power of kt multiplied with exponent to the power of c1. And we make the capital T as the subject, and we get capital T equals to capital C, which is exponent to the power of c1 multiplied with exponent to the power of kt plus 100. Next, given the condition that the temperature increases 3 degrees Celsius every minute, so we have the initial temperature equals to 25 degrees Celsius when the time, the small t, equals to 0. That's the initial temperature. So we substitute. The capital T equals to 25 equals to capital C times exponent to the power of k times 0, because we substitute the small t, the time, with 0, plus 100, and we solve it, we get capital C, which is the constant, equals to negative 75. So we have capital T equals to negative 75 times exponent to the power of kt plus 100. So we have another condition when the temperature increases 3 degrees Celsius from 25, which is when the temperature is equals to 28 degrees Celsius when the time is equals to 1 minute. Alright, so we substitute also capital T equals to 28 equals to negative 75 times exponent to the power of k times 1, because we substitute the small t, the time, with 1, plus 100 equals to 75 times e to the power of k equals to 100 minus 28, which is equivalent to 72. Making the exponent to the power of k subject, we have exponent to the power of k equals to 24 over 25. So we insert ln both sides. We have ln e to the power of k equals to ln 24 over 25. So we can solve the k. We have the k equals to negative 0.0408. So we substitute the k also in the general equation. We have capital T equals to negative 75 times exponent to the power of negative 0.0408t plus 100. So going to what the questions asked us for, we gotta find the t, the time when the temperature equals to 85 degrees Celsius. Alright, so capital T equals to negative 75 negative 75 times exponent to the power of negative 0.0408 t plus 100. Substituting the t, capital T, which is 85, we have exponent to the power of negative 0.0408 t equals to 15 over 75, which is simplified to 1 over 5. So to solve this exponential equation, we insert ln the both sides. So the left hand side would be ln exponent to the power of negative 0.0408 t equals to ln 1 over 5. Solving that, we have t equals to 39.4470, approximately 39.45 minutes. So in conclusion, it can be said that the time required for the metal bar to reach 85 degrees Celsius is approximately 39.45 minutes.
A tank contains of 300 liters of fluid in which 20 grams of salt is dissolved. Oil containing 1 gram of salt per liter is pumped into the tank at a rate of 5 liters per minute, and well-mixed solution is pumped out at the same rate. Find about 80 grams of salt in the tank at t time. From this question, we know that we have to find the amount of salt in the tank at t time. So, with the given information, we can find the amount of salt in the tank easily. So, let's get try.
If 80 is an actual amount of salt in grams in the tank, then dA over dt equal to R in minus R out, where R in is rate of inflow salts and R out is rate of salts being released. The rate of inflow salt is 5 grams per minute since we multiply the concentration of salt inflow with the input rate of brine, and the rate of outflow salt at any time is 1 over 80 grams per minute by multiplying the concentration of salts outflow with the output rate of brine. Then, substitute this value in the dE to get dA over dt equals to 5 minus 1 over 80. First order linear differential equation can be written as, from the equation, Pt equal to 1 over 60. Thus, the integrating factor is exponent t over 60. Now, multiply the dE by the integrating factor, we get. Next, integrate both sides of the equation with respect to t. Then, simplify to obtain At equal to 300 plus c exponent negative t over 60. Now, applying the initial condition where At equal to 20 at t equal to 0 to get c equal to negative 280. Substitute the value in the solutions. Therefore, the number 80 of grams of salt in the tank at time t equal to 300 minus 280 exponent negative t over 60.
Hope you understand what we have explained and learn something from it. On behalf of my team, I would like to apologize if there are any errors from our explanations. That's all from us. Thank you.